Okay, so again guys, welcome again sa subject natin, Physics for Engineers. This is lesson 5, Introduction to Oscillation and Simple Harmonic Motion. So last week we have an asynchronous session that tackles about work and energy. So if you haven't yet watched the video that I posted or have referred to in ULMS, please find time to watch that because we will be using the principles of potential and kinetic energy on our discussion for next meeting. Okay. But for today's meeting, we will be focusing on introducing to you guys the concept of oscillation and simple harmonic motion. Okay. So to start, at the end of the session, these are the things that I intend to impart to you guys at the end of this lecture. So first is to identify yung conditions of simple harmonic motion on the tawag natin as SHM. Then to explain how force, velocity, and acceleration changes as object vibrates with SHM. Then to calculate the spring force using yung Hooke's law. So we will be discussing or I'll be introducing to you guys what does the Hooke's law states. Then lastly is to calculate the period and frequency of an object vibrating with simple harmonic motion. Okay? Okay, let's start. So, can you look at this picture? So, what can you say about this picture? So, we have four pictures. So, we have a metronome, a pendulum, a swing, and a mass on a spring. So, what can you say about these photos? Anybody? Any idea kung anong pwede nating masabi sa mga picture na to?
Motion.
Come again? Pa-repeat po ulit. Motion lang narinig ko. Ano yung... sin- So kung tingnan natin, 'di ba, yung metronome, kung hindi kayo familiar, usually ginagamit sa music or sa psychology. Yun siya yung kapag tinik mo siya o hinawakan mo siya, tapos ni-release mo siya from your hands, bali magmo-motion siya ng ganun, yung metronome, yung first picture natin. Then we have a pendulum, 'di ba? Alam naman natin pendulum, once you pull yung isang ball, then release yung ball, magkakameron ng action dun sa other side niya, then continue siyang magpa-back and forth, no? Then same as the swing, no? Kapag meron tayong swing, meron tayong front and back na motion sa kanya. Then when we have a mass on a spring, anong nangyayari sa kanya? So once since spring 'yun, so may tendency siyang mag-recoil, no? So nilet go natin yung mass, may tendency siyang magkameron ng up and down motion. So anong pwedeng conclusion natin doon? Anybody? Hello?
Nag-o-oscillate po yung movement back and forth.
Yes, okay. So thank you. So bali nag-oscillate tayo. So pero ano ba yung ibig sabihin ng oscillation, no? So yung the images or yung photo shown has a repeating motion. So moving in a regular cycle. So as we can observe earlier, meron tayong left and right motion, meron tayong front and back, tapos meron tayong up and down motion. So this particular motion is considered periodic motion because it returns to the given position after a fixed time interval. Okay? So sometimes this motion is also called an oscillation. So meaning, kapag meron kayong movement na nagre-repeat lang yung cycle niya, no? Ang tawag sa kanya is oscillation. Okay? So, yan. So when we are talking about oscillation, we are talking about simple harmonic motion. So ano ba yung tatawag natin simple harmonic motion? So simple harmonic motion, so let's say we have a body that undergoes a periodic motion. So Um, it may be as yung displayed dun sa picture. So we have a block attached sa spring. Then when we try to pull yung block natin, so as you can see here, Meron tayong block. No? Ito yung block natin. Once we try to pull yung block natin, then once na nirelease natin, ang tendency ng body natin is to move, papunta dito, then babalik siya dito, babalik siya dito, babalik siya dito, babalik siya dito. So, nagkakameron siya ng repeated cycle ng pag-move niya so at certain distance, no? Na eventually, after some time, mag-stop siya dahil um, parang yung momentum niya is ano siya, mag tendency niya is to return to its original position, yung equilibrium position niya. Okay? So, a simple harmonic motion undergoes a periodic motion na merong stable equilibrium position. So, yung equilibrium position natin is, dito sa problem na to is, let's say, yung pinaka-equilibrium position natin is kung saan walang displacement na nangyayari kung x is equals to 0. So, as you can see on the second figure, so, kumbaga yun yung untouched niyang position. Then when we try to touch the block away from the body or try natin i-pull yung block as shown as the first figure, then when we try to release it, magkakameron ng net force o may force na nag-a-act sa kanya. Yung net force na to is um, being supplied by the spring itself, no? So yung spring na to, 'di ba, minove natin siya. So nagkameron tayo ng distance x from the initial position, yung initial position. Tapos minove natin siya ng dito sa position na to, no? So nagkameron tayo ng movement to the right. Okay? May movement tayo to the right. Then yung opposing na force na ini-exert ni spring para i-pull pabalik siya dun sa original position niya, ang tawag natin sa kanya is a restoring force. Okay? So yung restoring force na to, yung net force na yan, yung Fs, yung puno sa figure, is always opposite to sa direction ng displacement natin o ng movement natin. Since to the right yung movement natin do sa first figure, ang ginawa nung spring natin, nag-exert siya ng equivalent force na magbibigay ng opposite direction, na naka-apply opposite direction ng movement natin. Okay? So if the force that restores the object back to its equilibrium position is directly proportional to the displacement of the object, okay? So the motion is called simple harmonic motion. So as you can see on the third figure, when we try to release yung mismong block natin, since may force na humihila sa kanya, ibalik siya doon sa original position niya, no? Itong force na to. Once nirelease natin, hindi siya directly mag-start agad doon sa equilibrium. So, kumbaga hindi oppose agad yung motion natin. Ang tendency ng motion natin is to go or move more doon sa left side nung ano natin, equilibrium natin. Kaya nangyayari, kinocompress naman niya yung mismong spring natin. Ngayon si spring, since meron tayong movement na to the left, ang i-exert naman ngayon na force ni spring is ano, opposite direction ulit. So yung meron ulit siyang Fs na in-exert na to the right naman to bring the body or yung block natin to its original position. So maglalaro siya ng ganon hanggang eventually after some time is magbumalik siya dun sa original position niya. Okay? Pero kung halimbawa frictionless yung surface na pinag-uusapan natin, ideally dapat hindi titigil yung motion natin. So once na na exert ka ng o nag-indicate ka ng movement papunta dito, tendency ng body natin is to just oscillate lang forever, no? Hanggang hanggang forever na siyang gumalaw ng gumalaw. Pero ang concern natin ngayon is yung force na nagre-restore ng object back to its original position. So we need to identify yung force na yan para ma-distinguish natin na simple harmonic motion yung um, na raramdaman o na nag-e-exist dun sa mismong setup natin. Okay? So, when we are talking about the relation of the force with respect to this displacement of the object, pinag-uusapan natin ngayon is yung propose ni Hooke, no? So, ni Robert Hooke, yung tinatawag nating Hooke's law. So, ito si Robert Hooke, a British physicist. So, ni-state niya na ang force required to extend or compress a spring by some distance is directly proportional to that distance. Okay? So, force, may pinag-usapan tayong force. So, let us call that force Fs. Okay? And then, directly proportional siya doon sa distance. Okay? So, since nasa horizontal plane tayo, tawagin natin yung distance natin as x, no? So, ibig sabihin, any position dun sa horizontal natin. So, directly proportional daw siya dun sa distance natin. So, applying yung equation natin for directionality. Okay? So, Fs is equals to Kx. So, yung K natin is a constant na mag-indicate nung proportionality natin. Okay? So, yung K na to is a property of the spring na pinopossess niya. No? So, this is called a spring constant. Okay? So, a spring constant na ang unit is Newton per meter na nagva-vary siya ng value depending sa material, kung anong klaseng spring yung nakalagay sa setup ng body, depende sa diameter, depende sa kapal. So basically, usually given siya sa problem, pero pag hindi siya given sa problem, siya yung hinahanap. Okay? Basta siya is pinopossess siya ng mismong spring natin. Kung walang spring dun sa system natin, wala tayong spring constant na pinag-uusapan. Okay? So, kapag walang spring constant, so mahirap i-satisfy na merong simple harmonic motion. So, babalik lang tayo dun sa previous discussion natin ng kinematics na about friction lang yung movement natin, ano? Or sa unbalanced force lang. Pero since meron tayong spring constant na present, the tendency of the body is to go back and forth or to repeat a cycle. Kaya na satisfy natin na in simple harmonic motion yung given body natin. Okay? So to formally um, uh, present your equation, so same lang naman to. So yung directionality natin, Fs is directly proportional dun sa x. Yung Fs is equals to negative k times x. So as you can see, the negative sign is present here. Bakit? Kasi sabi natin kanina, si spring is nag-exert ng force na opposite nung direction ng movement natin. Okay? So, halimbawa yung movement natin is positive x. So, halimbawa to the right, yung movement natin. No? So, from initial position, ito yung initial position natin. Ito yung second position natin. No? So, nagkameron kayo ng positive x na movement. Ngayon, di ba sabi natin yung spring, ang i-exert niya is daring the opposite na direction ng mismong displacement natin. So, si force natin is paganto ang direction. Okay? So, to indicate yung reverse in direction, we need to represent yung value ng spring force natin as a negative sign. Okay? So, nakakalagay din naman dito na yung negative sign only tells us that F o yung spring force natin is what we call restoring force, and it works in the opposite direction of the displacement. So basta ang gusto lang niyang sabihin kaya siya nilagyan ng negative sign is opposite siya ng mismong displacement natin. Kung positive tong x natin dito, so yung dapat yung fs natin will be a negative value. So kung negative yung x natin, since meron tayong present ng negative, so negative times negative, yung fs natin will be positive. Okay? So yun lang yan. So then pinapakita lang din dito yung relationship ng force natin and dun sa distance natin. Here they're stating na kapag nag-increase tayo in or in-increase natin yung distance nung displacement natin, okay, magiging twice din yung value nung force natin, no? So, kaya nga siya directly proportional. So, si distance is dependent, no? Or yung value ng force is dependent sa distance. Kung halimbawa nag-quadruple yung distance mo, definitely yung value ng spring force mo will be quadruple. Okay? So, any question regarding Hooke's law so far? Hello?
None po.
Wala po.
Thank you. So, let's try to apply yung Hooke's law sa simple problems lang muna, okay? So, we have here a spring that is stretched by 10 centimeter and has a force constant of ito is baliktad yung unit, no? Dapat ito ay dyne per centimeter. Okay? Then determine the force applied. So, we have a given, in-stretch natin. So, ito yung x natin. Force constant, so meaning ito yung k natin. Pinapahanap is yung force applied. Okay? So, F is equals to negative kx. Okay? So, yan. So, we need to substitute. So, k natin is negative 2 dyne per centimeter, then 10 centimeter. Okay? Cancel out. So, we have negative 20 dynes. Okay? Ano bang ibig sabihin ng dynes? No? So, 100,000 dynes, okay, equals yan sa 1 Newton. Okay? So, since dapat ang force natin is in terms ni Newton, okay, or ni kilonewton, okay, so we need to convert this one. So, para ma-cancel out si dynes, dapat nasa ilalim siya. Times 1 Newton. Then, we try to convert yung Newton natin into kilonewton. So, 1 Newton is 1,000 kilonewton. Okay? So, ilan to? If 20 times 1,000 over 100,000. So, we have negative 0.2 kilonewton. Okay? So, again, yung sign natin is just pertaining dun sa opposite direction ng movement natin, displacement natin. Okay? So, kung halimbawa in-specify na yung 10 centimeter is to the right, so yung answer natin should be force natin o spring force natin is equal sa 0.2 kilonewtons to the left. No? Okay? Question?
None po.
Okay. Thank you.
Wala po.
Okay. Next. So, we have determined the force constant if a force of 100 Newton is stretching a spring by 0.8 meters. Okay? So, we have a force, yung Fs natin,
Sir,
stretching yung spring.
yung
Yes.
kanina po dun sa may kilonewton, saka newton, hindi po
Ay,
babaliktad.
baliktad, no? Sorry. Yes, thank you. Ngayon ko lang din nakita. So, dapat 1 kilonewton, 1,000 Newton. Okay, so thank you. So, this should be 20 over 100,000. So, lalo pa lang liliit, no? So, wag na natin gawing kilonewton. Okay, so gawin natin 20 divide 100,000. So, we have negative, so we have negative 0.0002 Newton or negative 0.2 millinewton. Okay? O yung answer natin is SF is 0.2 millinewtons to the left. Okay, so thank you for correcting. No? Baliktad pala yung kaninang ginawa ko. So dapat is 1 kilonewton is 1,000 newton. So yung nangyari dito, sobrang liit niya na 0.002 newtons. Then kinonvert ko lang yung madaming zero, yung tatlong zero into milli, no? Kaya naging million newtons. Or yung final answer natin will be positive 0.2 million newtons to the left. Okay? Okay na? Okay na? Okay? So, yeah, let's go back to the second question. Determine the force constant. Force constant, so pertaining siya sa K. So, may Fs tayo na 100 Newton stretching the spring by 0.8 meters. So, ito yung X. So, we have Fs is equals to negative Kx. Okay? So, since yung ano natin, value natin ng Fs is supposedly dapat lagi siyang opposing, no? So, negative dapat, no? So, dito, sa substitute natin is negative 100 newtons is equals to negative K times yung ano natin is 0.8 meters. Okay? So, yung K value natin will be a positive value. So, 100 divide natin by 0.8 both side. Okay? K value natin will be 100 divided 0.8. So, we have 125 Newton per meter. Okay? So, basically, direct substitution lang naman yung samples natin. No? As a introduction for Hooke's law. Okay? Okay? Now, we go to the next topic na natawag natin as sinusoidal motion. Okay? So, sinusoidal motion ang tawag sa isang motion if it undergoes the sinusoidal curve. Okay? So, ibig sabihin niya, yung curve natin has the shape of a trigonometric function, sine or cosine function. So, if you are not aware kung ano yung itsura ng functions natin na yan, so, bawa ito yung ano natin, cosine. Si cosine, kapag ginraph natin, is ang itsura niya is pag ganyan, no? Okay? So, ano yan? Sa infinite yan na ganyan yung wave niya, no? And then si cosine is ang kaibahan ni cosine ni sine, ang starting position niya or dumadaan siya dun sa origin natin. Okay? So, yan yung cosine and sine wave natin. Okay? So, ang simple harmonic motion natin, ma-identify natin siya as a sinusoidal motion kapag nagra-run through siya ng same path ng ganito. Okay? Pero sabihin ko na din for now na lahat ng simple harmonic motion natin ay lahat sila ay sinusoidal motion. Okay? So, yung property ng mga ng graph natin, ito, we have yung amplitude, yung period, and frequency. So yung definition niya, yung amplitude natin is yung maximum displacement of the moving object from its equilibrium position. So ano yung tatawag natin equilibrium position? Yung equilibrium position natin is yung x-axis natin. Ano? So ito yung position natin. Okay? So, syempre kung baka may nakakaisip sa inyo, simple harmonic motion pinag-uusapan natin. So kung may simple, definitely may complex, no? Okay? So sa subject matter natin ngayon, simple harmonic lang yung pinag-uusapan natin kasi yung equilibrium position na pinag-uusapan natin is only one. Okay? So yung position na yan is yung horizontal axis natin. Okay? So in other cases kasi kapag complex na yung mismong motion natin, harmonic motion, so pwedeng nangyayari, dito siya nag-oscillate, then upon some time, nag-change siya ng ng oscillation, no? So, ibig sabihin meron siya ditong equilibrium na position, meron din siya ditong equilibrium position. So, itong matter na to, hindi na natin sasakupin. Ang focus lang natin is simple harmonic motion lang, which signifies or suggests na ang ating equilibrium position is only 1. Okay? Again, amplitude yung tawag dun sa height, no? So, as you can see dito sa picture na to. So, ibig sabihin, itong sa ilalim, amplitude din yan. Okay? Yung offset nung yung maximum distance or displacement natin from the equilibrium position. Okay? So, ibig sabihin, negative lang yung value nito kasi below siya nung axis natin, ano? Then yung sa taas, positive yung value. Okay? Then we also have yung period. Yung period natin is yung time it takes to take one full cycle of motion. So, ano yung cycle na tinatawag natin? Yun yung pag-return ng mismong body natin dun sa initial position niya. So, halimbawa, yung body natin, ang initial position niya is ito. Okay? So, once na nag-move na tayo, di mag-move siya dito ulit. Tapos, ang one cycle niya is pagbalik niya dun sa same position na yan. Okay? So, ibig sabihin, mag-move siya dito, mag-move siya doon. Okay? So, kung dito, ito yung position na yan. Ito yung tinatawag natin one cycle. Okay? Then yung time na ita-take natin to complete that cycle is tinatawag natin period or T. Okay? Kaya may nakalagay na period dyan. Then yung frequency natin is meron siyang relationship with the period na yung number of cycles or vibrations per unit of time. So later we will discuss yung formula or equation pertaining sa relationship ng frequency and period. Okay? So, ito lang, papakita lang natin kung paano nagiging sinusoidal motion yung mismong spring and mass na system natin. Ano? So, as you can see dito sa picture natin, so we have a ball attached to a spring, and then nag-attach tayo ng pen dun sa spring. Then once we try to, from the initial position, so ito yung isang initial position niya. No? From the initial position, we try um, to pull yung ball natin hanggang dito sa extent na to. So, naka 3D yan, kaya ito yung position na yun. No? Then, when we try to release that, ang gagawin ng ball natin is to oscillate, no? So, magiging ganito yung, ano niya, yung direction niya. So, yung sa pen natin, since gumagalaw yung ating itong recording ano natin, na kada movement ng ball natin, na tatraverse siya dun sa sinusoidal motion natin. So, sa cosine and sa or sine wave natin. Kaya, sinasabi natin na lahat ng simple harmonic motion natin is a sinusoidal motion. Okay? So, basically, from the maximum displacement o yung measured natin amplitude sa positive, then pupunta siya dun sa negative, punta siya sa positive, positive, negative, and so on and so forth, no? Hanggang ma-produce natin tong line na to. Okay? So, yung graph natin is basically yung x direction natin, yung x natin, ay yung or vertical ano natin is yung displacement. And ngayon, yung horizontal natin is time, no? Displacement. Okay? So, yun yung kaibahan ngayon. Dati ay, di ba, x, y tayo. Ngayon, time and x tayo, no? So, displacement, yung vertical direction natin, then horizontal natin is time. Okay? So, kapag sinusoidal motion yung pinag-usapan natin, we have certain formulas na kailangan tandaan or take into consideration to be able to understand or calculate yung mga pinag-usapan natin kaninang period, frequency, saka amplitude, no? So, let us start with the period and frequency. So, si period, um, for this course, we will not be deriving kung saan ang galing yung formula na yan. Pero in your higher mathematics, no, if next semester meron na kayong differential equation, you may ask kung sino man maging professor nyo kung paano ma-derive yung t is equals to 2 pi squared of m over k. No? Pero for now, consider nyo lang siya as a formula na kailangan yung tandaan na kapag hinahanap yung period o yung time to complete one cycle ng mismong motion natin, the formula is 2 pi squared of m over k, where m is yung mass ng object natin and yung k is yung ating spring constant. Okay? Then the resulting number or yung the value that we will be having using this formula is in terms ng seconds kasi period yung pinag-usapan natin. Ano? Then, again, yung sa frequency, ang relationship ng frequency and time period is reciprocal with each other. No? So, ibig sabihin, to get the frequency, you just need to get the reciprocal of the period or 1 over t. So, kung seconds yung unit nung nito, so ibig sabihin 1 over s yung unit natin ng frequency. And in physics, ang 1 over s is known as hertz, no? So we use yung term na hertz or Hz, no? Kung na ano nyo sa radyo, no? Hertz as representation ng unit na 1 over s or 1 over second. Okay? And then we try to represent yung value ng position nung um, position ng object natin at any time. So, ibig sabihin, kung halimbawa may given particular time period, so we have two conditions na pwedeng consider. Pwede tayong gumamit ng cosine wave or yung sine wave natin. So, basta alam na natin pagkakaiba ng dalawa, no? So, basically, yung formula niya is distance or displacement is equals to A, yung amplitude natin. Okay? Amplitude, cosine, 2 pi t. Small t is time, no? So, usually given. Then t is time period. Okay? And then, kung meron tayong displacement, we can also identify yung velocity and acceleration natin using tong formula ng displacement. So, any idea from anybody kung paano natin makukuha yung velocity and acceleration using this formula?
Ano, final velocity minus initial velocity over time.
Okay, so for this case, tama yung formula natin na sinabi, no, yung final velocity minus initial over time. Pero hindi, ang given lang natin is yung displacement lang, no? So, sabihin, unknown pa din yung velocity, tapos yung time wala tayong start, wala tayong end na velocity. So, what we can do is to apply differential calculus, no? So, kapag nakakita kayo ng displacement function, so bawa yung displacement na function, or let's say for this example yung xt is equals to a cosine 2 pi t over t. Pwede natin makuha yung velocity and acceleration natin using differential calculus. So, in differential calculus, kung ang displacement natin, okay, displacement natin ay xt. So, para makuha natin ang velocity, what we need to do is to get the first derivative nung xt natin. Okay? So, ganyan. Or, dito sa physics, ang representation natin is may dots, may isang dot dun sa itaas niya. Ibig sabihin first derivative. Okay? Then, si acceleration, para makuha natin siya, we need to get the second derivative nung displacement natin. Okay? So, kailangan kunin natin yung differentiation ng formula natin. Okay? So, let's try. So, yung displacement formula natin, again, is xt is equals to a cosine of 2 pi over t times t. Yan. So, ito yung displacement natin. So, para makuha natin velocity, again, first derivative tayo. So, tanda pa kaya ang derivative? Okay. So, we get the first derivative. Okay. So, kailangan tingnan natin yung given natin. So, si A is amplitude. Treated yan as constant. No? Then, si 2 pi over t is, since yung ano natin is in terms si time, no? Yung displacement natin, in terms in time. So, ibig sabihin, itong 2 pi over t natin, treated also as constant. So, basically, ang dinederive natin is yung trigonometric function lang natin. Okay? And what is the derivative of cosine? Derivative ng cosine?
Negative sign po. Negative sign.
Okay, good. So, negative sign. So, we have ang derivative ng cosine of u is equal sa negative sign ng u times yung derivative ng u natin. Okay? So, for this example, ano ang u natin? Ang u natin ay dun sa given formula natin.
2 pi t over t po.
Okay? 2 pi over t yung u natin. So, ang du natin ngayon or ang derivative natin ngayon ng cosine is negative sine 2 pi over t times anong derivative ng u natin? 2 pi t t. Okay. Ano ang du natin? So, kung treated as constant yung 2 pi over t, anong du natin? Okay, ito, treated as constant. So, parang ct lang siya. No? So, ano ang derivative nun? Anong derivative ng ct?
2 pi over t din po.
Okay? So, 2 pi over t lang. No? Nawala na yung t kasi, di ba nga, ang ano natin, xn. So, ang derivative natin is n, xn minus 1. Okay? So, yung t natin, may 1 sa utaas. So, magiging siyang 1, t, 1 minus 1. So, 1, t raised to 0 or 1. So, ito times 1. So, 2 pi over t lang. Okay? So, you need to review your differential calculus. Okay? So, ang du natin dito is 2 pi over t. So, ibig sabihin, ang derivative natin for this is apply na natin ito sa kabila. So, negative a times 2 pi t sine of 2 pi t t. Ito, nawala yung t dito. Wait. Yan. Okay? So, ito yung magiging velocity natin. Okay? Then, para makuha yung acceleration natin, we need to differentiate ulit yung velocity natin, second derivative. So, ito is constant ulit as well as ito. So, ano ibig sabihin? Ano ang derivative natin ng sine?
Cosine po.
Okay?
Cosine.
So, pwedeng copy lang natin to. Then to will be cosine 2 pi t times t And derivative ng nasa loob niya is same lang nung kanina, 2 pi t lang ulit, no? So simplify, we have negative a, then 2 pi over t squared, cosine of 2 pi over t. Ito yung ating acceleration. Okay? So, ganyan yung pagkuha ng velocity and acceleration kapag given tayo ng function ng displacement, no? In terms ni time. So, no need mong i-memorize yung velocity and acceleration as long as marunong kang mag-derive. Okay? So, paano natin yung papasimplify ito? So, tingnan natin yung given natin. So, we have 2 pi over t. So, tingnan muna natin yung 1 over t, no? Ano ang 1 over t? Equals yan sa?
Hertz po.
Saan? Sa hertz? Anong tawag natin doon sa hertz?
Frequency po.
Okay? So, equal siya sa F. So, ibig sabihin, pwede natin i-represent yung xt natin sa displacement natin, no? Na A cosine 2 pi ft. Okay? Pwede siya maging ganyan din. Then, si 2 pi ft, mayroon siyang special na tawag sa kanya. Ang tawag sa kanya is angular frequency. Okay? So, denoted siya by the symbol omega. Okay? So, ibig sabihin, pag pina-simplify pa natin ulit, si displacement equation natin is also A cosine omega t. Okay? So, may dalawa tayong formulang nakuha, no? So, omega is equals to 2 pi f. Okay? So, kung ganyan na lang yung displacement equation natin, so yung first derivative natin will be negative A sine of Wt omega, okay? Or negative A omega sine of omega t. Okay? So, ito yung displacement equation natin. Velocity equation. Then, acceleration equation natin is derivative lang ulit nung given natin sa taas. So, negative A omega cosine of omega times omega. So, simplify natin. This will be negative A omega squared cosine of omega t. Okay? So, this will be your displacement, your velocity, and your acceleration equation. Okay? Kasi baka magtumingin ka ng ibang references, ganyan yung pagkakasulat sa kanya. So, pwedeng ganito din yung pagkakasulat nung sa displacement. So, kunin nyo na lang yung velocity and acceleration niya in terms ng F. Then, ito yung isang condition natin kapag yung gantong form naman siya. Okay? So, again, no need to memorize these formulas. Siguro yung relationship lang nung frequency, nung angular frequency, tsaka yung ito lang, yung sa displacement equation natin. And you don't have to worry yourself about the others, no? Okay? Question before we proceed sa example problems. So, baka na-shock din sa dami ng formula na meron tayo ngayon. So, to lessen yung burden, we need to apply this equation sa example, no? Para mas ma-appreciate natin. Okay? So, let's proceed. So, we have an 8 kilogram object on a spring with a spring constant of 1.2 newtons per meter is undergoing SHM, no? Sorry, baliktad. at an amplitude of 50 centimeter. How far is it from its equilibrium position after 5 seconds? Okay. So, how far? So, how far ang tanong? So, ibig sabihin, displacement yung hinahanap natin, no? So, we have value ng M. Okay. Then, meron tayong value ng K. Then, meron tayong amplitude, no? A. So, ibig sabihin, kailangan natin ng value ng XT. So, which XT yung gagamitin natin? So, if ever walang nakalabigay kung anong wave yung consider natin, so, pinaka, ang by practice, laging cosine wave yung ginagamit na equation. Ano? So, we have x of t is equals to a cosine. Then, ang mga given natin is, so depende sa given yung gagamitin mong formula, no? So, we have k value. So, pwedeng 2 pi yung original na given natin at t. Okay? So, before you substitute, you need to make the units the same, lahat, no? So, dito ang wala tayo sa formula na to is yung value ng t. Pero anong formula ng t? Formula ng t is yung kanina. Walang nag-take notes. Okay, formula ng period is 2 pi square root of m
M over
k.
K.
Okay? So, pwede natin i-calculate na muna to. No? So, we have 2 pi square root of m over k is 8 kilograms all over 1.2 Newton per meter. So, T natin is equals to, makikipindot po kung marunong pumindot ng calcu. Ilan yung value natin in seconds?
$16.22 po.
Okay? 16.22 seconds. Okay? And then, we can now substitute. So, meron tayong given na time. Time natin is 5 seconds. So, amplitude daw natin, 50 centimeters. So, i-convert natin sa meter. Okay? So, equivalent yan sa 0.5 meters. Okay? And we have cosine. Then, 2 pi all over 16.22 seconds times yung time natin na 5 seconds. Cancel out yung seconds. So, anong value ng xt natin? Okay, so in calculating dito sa part na to, dapat ang value ng ating dapat yung calculator natin is naka-radian para maging tama yung sagot nyo. Okay? So, anong value makukuha natin? Dapat naka-radian yung calcu. Ibig sabihin, yung letter na nakalagay dun sa ibabaw nung ano natin. So, dito, no? Dapat letter R ang nakalagay. No? So, pwede yung mabago, shift mode. Tapos, select mo rad, number 4. No? Pero kailangan ibalik yan sa, sa degrees. Okay, sa 4. So, para maging R yung nandun sa taas niya. Okay? Anong value na kukuha?
Negative 0.178. 179 po.
Okay, so we have negative 0.179. Okay, so anong unit ito? Meters, no? So, negative sign indicates na, ano ibig sabihin ng negative sign? So, kung ito yung, halimbawa, cosine wave natin, no? So, halimbawa, ito na yung cosine wave natin. Yung position na 0.179 in 5 seconds, is nasa ilalim ng axis natin. Okay? So, ibig sabihin siya ay below the equilibrium position. Okay? So, sabihin natin, halimbawa, ito yung 5-second mark, no? Halimbawa, ito yung 5-second mark. So, halimbawa, andito siya sa part na to. Okay? Okay ba tayo doon? Ano pa yung pwede nating ma-observe dito? So, yung value natin ng amplitude is 0.5, no? 'Di ba? Amplitude natin is maximum 'yan. Maximum na distance mula doon sa equilibrium position natin. So, ibig sabihin, yung 0.5 na 'yon, ito 'yon, no? Ito 'yan, 0.5. Then itong sa ilalim, 0.5 din 'yan. So, ibig sabihin, dapat yung value ng x natin is in between ng range na to. No? Kasi ang maximum value natin is negative 0.5 tsaka 0.5 lang, no? Kaya since nakuha nating value is negative 0.179, yun yung tama yung answer natin na within siya dun sa limit natin na negative 0.5 and 0.5 or dun sa maximum amplitude natin or sa maximum displacement which is yung amplitude natin. Okay? Any more question? May mali pala ako dito sa figure, no? So, dapat hindi dito yung ano ko. So, makikita nyo, ang na-calculate nating period is 16.2 seconds. Okay? So, ibig sabihin, para ma-complete nyo yung same position na to, sabihin dito sa position na to, ito yung first period niya, di ba? Ibig sabihin, yung time na natin agad dito is 16.66 na agad yan. So, ibig sabihin, yung 5 seconds is somewhere dito sa point na to. No? So, yan yung pwedeng sabihin natin time is 5 seconds. Okay? Para tama lang yung figure natin. So, for this problem, yung answer natin is this one. Okay? Question? Hello, andyan pa kayo?
Yes po.
Okay?
Opo.
Okay tayo dito?
Opo,
Opo.
sir.
Okay. Next, a horizontal spring with constant of 300 Newton per meter with a mass of 0.75 kilograms attached to it is undergoing a simple harmonic motion. Calculate air, period, frequency, and angular frequency of this oscillator. Okay? So, meron tayong spring na ito yung K niya. Mass natin, ito, M. Okay. Pinapahanap is period. May given tayong M at K. Ang formula natin ng period is 2 pi square root of M over K. Substitute 2 pi. So 0.75. Ilan po makukuha natin? Period natin is ilan? Hello. Ilan?
Sir, wait lang.
Okay. Yung iba, please practice, no?
0.31.
Okay, so 0.31. Gawin ko lang 3 digits sa 314 seconds. Okay? So, may nag-chat. Okay, tama naman, Mr. Dalion. Okay, so ito yung first answer natin for period. Next, Frequency. Frequency natin, formula again is reciprocal ng period. So, ang value natin, 1 over 0.314 seconds. So, ang frequency natin ilan? Okay, so 3 point, gawin ko lang 3 years ulit, 3185 Hertz. Okay? Last, angular frequency natin. Angular frequency is yung omega natin. Ano yung formula niya kanina?
2 pi F po.
Okay, 2 pi F. So, substitute lang natin. 2 pi, value ng F natin is 3.185. Hindi natin gagamitin yung hertz. Gamitin natin is 1 over second. So, equals yan sa ilan?
20.01 po.
20.012 radian per second na lang gamitin natin. Ano? So, yun ang unit ng frequency, ng angular frequency. Okay? Question for this problem?
Wala po.
Okay. I hope yung iba nakakasunod, no? Okay, next.
Sir, excuse me po.
Yes.
Sir, may next po kaming klase. May presentation po kami.
Hanggang 4 tayo, di ba?
3:30 lang po ata.
Hindi, hanggang 4 schedule natin.
Ay, sige po, sir.
2:30 to 4 tayo. Tama, di ba? 2:30 to 4 tayo.
Yes, sir.
Okay.
Opo.
Next. Okay, so a force of 500 Newton is used to stretch a spring with a 0.5 kilogram mass attached to it by 0.35 meters. What is the value of spring constant? Calculate the frequency of the oscillator. Okay, so force natin, may Fs tayo ng 500 newtons, 0.5 kilogram na mass, then meron tayong distance. So Fs, meron tayong mass, meron tayong x. Unang tanong, what is the spring constant K? Okay? Anybody kung anong sagot? Value ng K? So, anong formula gagamitin natin? Na may relationship ng F, M, or X, we can use Hooke's law. Okay? Hooke's law natin is Fs, Hooke's law negative, Kx,
KX.
no? So, since dapat, di ba, negative yung sagot natin ng 500 newtons, so gusto negative, K, X natin is 0.35 meters. Okay? So, cancel out to. We have K is equals to 1428. Okay? Tama si Mr. Javier. 28.557 Newton per meter. Ito yung value ng K natin. Then, how can we calculate yung frequency? We need yung value ng period natin. Okay? So, period natin is equals to 2 pi square root of m over k. Then, substitute natin 2 pi square root of 0.5 kilograms divided by 1428 Newton per meter, 0.57. 0.57 Newton per meter. So, ang period natin is equals to ilan? Okay. Thank you, Mr. Rebeliosa. 0.118 seconds. Okay, or 1.2. Pwede din, no? Okay, then frequency natin, 1 over 0.118. So, ilan? F natin will be
8.475.
okay, 8.475 hertz. Okay, don't forget yung unit, hertz. So, depende sa pagkaka-round off, pwedeng 8.51, 8. No? So, depende kung nabawa 0.12 yung ginamit mo, you have 8.33. Okay? Okay, okay tayo dito sa example na to. Okay, next. Okay, a spring with a constant of 100 Newton per meter but vibrates at 25 hertz. What is the frequency of vibration? Ano? Yes? Ano yun, Mr. Romano?
Wala po. Akala ko lang po eh.
Okay, okay. Okay, so yung question again, meron tayong 100 Newton per meter na spring constant, nag-vibrate daw siya ng frequency na 25 Hz. Then, what is the frequency of vibration of a spring with a constant of 400 Newton per meter? So, anong nangyari? Nag-increase o nag-times 4 yung spring constant natin. So, pinapahanap is ano yung magiging vibration niya after natin i-gawing times 4 yung spring constant natin. Okay? So, pag mga gatong problem, pwede natin gawin is to formulate yung ratio and proportion. Ano? So, we have F2, yung frequency ng pangalawa, frequency ng una. Formula ng frequency is 1 over T. Okay? Or 1 over 2 pi. Tapos, pwedeng gawin natin K over M. No? Sige, baka mabiglang magtanong bakit naging ganun. So, ito ay 1 over period nung pangalawa, 1 over period nung una. Then, 1 over 2 pi square root of K, M over K2. So, yung mass natin hindi naman nagbago. Walang sinabing binago yung mass. Okay? Then, 1 over 2 pi square root of M over K1. So, mangyayari dito, pwede mag-cancel out ito. Okay? Matitira is square root of, so this can be reciprocated, no? So, this will be K2 over M over square root of K1 over M. So, this can be equal to negative square root of K2 over square root of M over square root of K1 over square root of M. Cancel out natin yung square root of M. We will have square root of K2 over square root of K1 or square root of K2 over K1. Yan yung equivalent ng F2, F1 natin. So, since meron tayong given ng F1, meron tayong K1, meron tayong K2, no? So, kailangan natin is si F2. So, si F2 natin is equal sa cross multiply natin F1 times square root of K2 over K1. So, substitute natin, F1 natin is 25 Hertz, square root of, so 400 Newton per meter, divided by 100 Newton per meter. Cancel out natin. F2 is equals to 25 times 400 over 100 is 4. Square root of 4 is 2. So we have 50 hertz. Okay? So, based from this relationship, makakonclude natin na si F is also directly proportional dun sa square root nung spring constant natin. So, ibig sabihin, kung ang spring constant natin is magko-quadruple, so ano nangyayari sa atin? So, kapag yung spring constant natin is naging 4 times, so magiging siyang 2. So, ibig sabihin, ang value mo ng S will be times 2, no? Twice nung value mo nung una. Okay? Kung halimbawa F2, F1. Nakukuha? So, kung halimbawa, gawin mong yung K value mo, gawin mong 9 times, no? So, halimbawa, ang unang value mo ng K1 is 100 newtons per meter. Tapos, in-increase mo siya 9 times, naging 900 newton per meter. Then, kung halimbawa, yung frequency mo, nung 100 pa lang siya, sabihin natin, 20 hertz siya, no? So, si F2, makukuha mo kapag kinuha mo yung ito, yung multiple niya is 9 times siya, no? So, square root of 9 is equals to 3. Tapos, yung 3 na nakuha mong value, multiply mo dun sa F1 mo. So, magiging value ng F2 mo is 60 Hertz. Ibig sabihin, 60 Hertz. So, pag in-apply natin dun sa formula, pag itong formula to, apply natin dito. So, mangyayari sa kanya, 20 square root of 900 over 100. So, same lang. 20 times 3 or 60 hertz. No? So, yun lang yung pwede nyo idagdag sa mga formulation natin. Yung relationship ng frequency and ng K value. Okay? Okay. Question dito? Okay. So, last problem. So, a 75.75 kilogram mass vibrates according to equation. Ito yung displacement equation natin. Determine the amplitude, the frequency, the period, the spring constant. Then dagdagan ko to, the velocity, no? Velocity after 5 seconds. Tsaka yung acceleration after 5 seconds. Okay? So, yung formula natin equals sa 0.65 cosine of 7.35 t. Unang tanong, what is amplitude? Yung value ng A natin. Anong value niya? Pag tinignan nyo yung equation natin, ito ay xt. Di ba original formula natin ay A cosine of 2 pi t t. Okay? So, ibig sabihin, itong constant natin sa unahan is yung value ng amplitude natin. Okay? So, ibig sabihin, pag hinahanap yung amplitude natin is equals to 0.65. Okay? Next, frequency. Anong value ng frequency? Value ng frequency. So, pag tinignan ulit natin yung formula dito, yung 7.35 dito, pertaining siya doon sa 2 pi over t natin dito. Or doon sa formulation natin kanina, di ba pwede natin represent din to as A cosine of omega t. No? And omega, alam natin, equals sa 2 pi f. No? Na doon sa given natin, ang omega natin is equals sa 7.35. So, pwede natin makuha yung value ng frequency. So, frequency is equals to omega over 2 pi equals 7.35 over 2 pi. So frequency natin is equals to 1.17 hertz. Okay. Next, period. So period is just a reciprocal. So 1 over 1.17 hertz. So T is equals to 0.855 seconds. Then spring constant natin is saan natin pwede kunin sa spring constant? So pwede natin kunin sa formula ng pwedeng period or frequency, no? So kung sa period, 2 pi square root of m over k. So para makuha natin yan, this will be t over 2 pi equals to square root of m over k. Then square natin both side. Magiging siyang t over 2 pi squared is equals to m over k. Pero ano nakikita nyo dito? 2 pi over t. Pag na-reciprocate natin both side ng equation, this will be 2 pi over t squared is equals to k over m. Ito is equivalent sa angular frequency. So, ibig sabihin, angular frequency squared is equals to k over m. So, si k can be omega squared times m. Okay? So, yung value niya, omega squared. So, 7.35 times 2 times yung 0.75 kilograms natin. So, lagay ko na lang dito. Sa D natin, K is equals to 7.35 squared times 0.75 kilograms. Answer is 40.52517 Newton per meter. Okay? So, yan yung first 4 sa question natin. Okay. Next is yung velocity and acceleration natin. Okay? So, yung given problem natin, xt is equals to 0.65 cosine of 7.35t. Okay? Given a time is equals to 5 seconds. Kunin daw natin yung velocity after 5 seconds. So, ito is i-derive lang natin. So, we have negative 0.65 sine of 7.35t times 7.35. Okay? This will be so negative 47775 sine of 7.35t. So, substitute natin yung value ng t, 4.7775 sine of 7.35 times 5. So, that will be 4.7775 sine 7.35 times 5. Okay, so we have 3.884. So, meter per second as velocity. Okay. Then for acceleration, i-derive lang natin yung first derivative natin. So we have negative 4.7775 times cosine of 7.35 t times 7.35. So this will be negative 35.115 cosine of 7.35t. Then substitute lang natin yung value ng t, which is 5 seconds, equals to negative 35.115 cosine of 7.35 times 5. So we have negative 20.451 meter per second squared as yung ating acceleration. Okay? So, binilisan ko na kasi alam ko wala na kayong di po ba negative ang alin? Negative 3.884. No, positive siya kasi naka-radians dapat yung ano mo. 4.775 sine 7.35 times 5. Positive siya kahit naka-negative yung value. No? Okay? So, yan. So, yan yung, yung velocity and acceleration natin. Okay? So, question for this problem. Okay? So, again, para makuha yung sagot dito sa displacement and dito sa velocity and acceleration natin, your calculator should be in radians. Okay? So, pag i-check natin yung position natin, kapag 5 seconds, no? Times 5. So, ang value natin yan is 0.379, which is pasok dun sa amplitude limit natin, ano? Okay? So, yun. Okay? So, question? More question? So, if you don't have any more question, you may review this recording and yan, tsaka na lang kayo mag-ask ng question sa akin sa Facebook. Okay?